This is geometry, note section 16.3, focusing on reference triangles. First definition, which I regret putting this in these notes. Unit circle, a circle with radius 1 whose center is at the origin. This is an important concept, but let's move past that for now. Let's focus on this. So let's say this is just a random circle whose center is at the origin. It doesn't have to be a unit circle. We are going to focus on a reference angle. Let me define that for you. A reference angle is acute, and it's formed by the x-axis and the terminal side of an angle. So for example, if I have the terminal side end up being here, well, what is a reference angle? First of all, it has to be acute. So this is an acute angle. This is an acute angle. Nothing else in here is acute. So it's either that angle or that angle. It's formed by the x-axis and the terminal side. So this is the terminal side. This is the x-axis. So in this example that I'm pointing out here, this would be the reference angle. We'll denote that with R for reference angle. If I had terminal side over here, this is an angle in standard position, this would be the reference angle. It's acute. It's formed by the x-axis and the terminal side. If I had the terminal side in quadrant 4 or in quadrant 3, these are where the reference angles would be. So this would be the reference angle. This would be a reference angle. Reference angles are formed by the x-axis and the terminal side, and they are acute angles. So with that, we have a reference triangle. I could have left that stuff there, but I am going to draw another one of these circles. A reference triangle is a right angle in the coordinate plane with an acute angle at the origin and one leg is an x-axis. So a reference triangle is a right triangle that uses the reference angle. If you had an angle in quadrant 1 whose terminal side falls in quadrant 1, like so, let's call this angle theta. The reference triangle would be a right triangle formed by drawing a vertical segment and that the x-axis was one of the legs of the triangle. Now with this being said, obviously this is x and this is y. X is the distance from the center to here, that's x, and y is the vertical distance, that would be up here. The radius would be the distance from the center of the circle to the circle. Cosine of theta is defined as the adjacent leg over the hypotenuse. If you're using a reference angle, the adjacent leg will always be x. And if you're drawing this in the coordinate plane and the center is at the origin, the hypotenuse will always be r. So what I'm telling you is, if you have a reference triangle, cosine of theta is always x over r. X will always be the adjacent leg, r is always the hypotenuse. Sine of theta, sine is the opposite leg, which is y in this case, over the hypotenuse, which is r. If you're using a reference angle and a reference triangle, the opposite leg is always y, the hypotenuse is always r. Let's look at some other possibilities. Let's say that the reference angle ends up being in quadrant 3. Well, if you make your reference triangle in quadrant 3, and you got theta here, x is the adjacent leg and y is the opposite leg. Doesn't matter where you draw it. If we were to draw this in quadrant 3, x is the adjacent leg, y is the opposite leg. Happens in quadrant 4 as well. So what I would like you to memorize is that if you have a triangle drawn in the coordinate plane with a reference triangle, cosine of x is x over r, cosine of theta is x over r, sine of theta is y over r. Also along with this is tangent. Tangent is the opposite leg, which is y, over the adjacent leg, which is x. Since theta is the reference angle, y and x will always be the opposite and adjacent legs, respectively. Let's see if we can apply this. Number 1, find sine of theta. We have this angle drawn, and this angle goes through the ordered pair -3, 4. To do this problem, you need a reference triangle. A reference triangle is a right triangle in which the hypotenuse is the terminal side and that one of the legs is the x-axis. One of the legs is always on the x-axis. In order to do these problems, we have to know what x, y, and r are. We're told x is -3, so in this triangle, this is -3. We're told y is 4, so in this triangle, y is 4. What we don't know is we don't know what r is. This is an example, I think it's the first time this happened in this class, where we are saying that this length in this triangle is a -3. Because we're going left. Left means negative in this context. So to figure out what r is, this is a Pythagorean triple. It's a 3, 4, 5. If you don't remember that, then do the Pythagorean theorem and you'll figure out that r is plus or minus 5, and the radius will always be positive. X and y can be positive or negative, but the radius is always positive. Well, sine of theta, we just learned that sine is y over r. And in this case, this angle down here is theta. We would call this reference angle in here theta prime. That's the reference angle. Prime just means new or derived from. So in that triangle, what is y? It is 4. What is r? It is 5. Therefore, sine of theta is 4 over 5. If you happen to also be asked, which you weren't, but what's cosine of theta? Well, that's x over r. X is -3 and r is 5. If you were asked what's tangent of theta, which you weren't, but if you were, tangent's y over x, opposite leg over adjacent leg, that would be 4 over -3. Number 2, if t is -3, -6, find cosine of theta. This is in quadrant 3. So if we go 3 left and down 6, that's going to put us down here somewhere. Draw a segment that goes through that point. Make a reference triangle. One of your legs is the x-axis. We're going to have a reference angle. So we could call this theta, or if you wanted to go in this direction, this is theta. That makes this reference angle here theta prime. In this triangle, we were already told that x is -3 and that y is -6. What we don't know is we don't know what r is. This is not a Pythagorean triple, so we're going to have to use the Pythagorean theorem. X squared plus y squared equals r squared. The reason we have to use the Pythagorean theorem is because cosine of theta is x over r. And we know x is -3, but we don't know what r is. So x is -3, and we're supposed to square that, plus y is -6, we're supposed to square that, and we don't know what r is. -3 squared is 9, -6 squared is 36, Add those, you get 45. If you square root both sides, you get plus or minus the square root of 45 is r. 45 is not a perfect square. However, this can be reduced to 3 square roots of 5. 3 times 3 is 9, times 5 is 45. This is positive because the radius will always be positive. There are exceptions to that, but not in this class. So cosine of theta is x over r. It's negative 3 over 3 square roots of 5. We can reduce this. We can divide the top and bottom by 3 and get negative 1 over the square root of 5. If we rationalize our denominator by multiplying this by 1 in the form of square root of 5 over square root of 5, we would get negative square root of 5 over 5. Let's go to the back. Given theta is in quadrant 4 and sine of theta is negative 3/5, find cosine of theta. This seems really abstract and difficult. It is neither. We know that sine is associated with y over r. So that means this fraction is equal to y over r. So that means that sine of theta, first of all, where does that negative go? Does it go on the top or does it go on the bottom? Well, since r has to be positive, that means the bottom has to be positive. And since y is in quadrant 4, that means y has to be negative. So we know for sure that y is a negative 3 and r is a positive 5. If we draw theta so that it terminates in quadrant 4, we make a reference triangle. Your reference triangle always uses the x-axis as one of the legs of the triangle. So we know y is negative 3. We know r is 5. We don't know what x is. You could use the Pythagorean Theorem, or if you recognize this is a Pythagorean triple, this is a 3, 4, 5. So the x value is 4. So what is cosine of theta? It is x over r, so it's 4 over 5, it's 4/5. Number 4, supposed to find sine, cosine, and tangent of this. If you remember, it looks like this is a reference angle because one of the legs is horizontal. So we could say that sine is y over r. Opposite leg over hypotenuse, that would be 5/13. Cosine of theta is x over r. Adjacent leg over hypotenuse. Tangent of theta is y over x. Opposite leg over adjacent leg. In each case, you're going to be given two of the things, x, y, or r. You just got to find the third with the Pythagorean theorem. Given that theta is between pi over 2 and pi, what does that mean? I'll tell you what it means. This means we are in quadrant 2. Let me explain how I know we're in quadrant 2, and then we'll read the rest of the problem. If you label the quadrantal angles, we got 0. If we go all the way around, we're at 2 pi. Halfway around, we're at pi. Halfway between 0 and pi, we're at pi over 2. So we got 0, half a pi, a full pi, and then we're going to have 3 pi over 2, then 4 pi over 2. So this says that theta falls between pi over 2 and pi, so that means that we know that we are in quadrant 2. So we draw a reference triangle. A reference triangle always uses the x-axis as one of the legs. Then we're told that sine of theta is 8 over 17. So 8 has to be y and 17 has to be r because sine is y over r. So we got 8, we got 17. We just need to figure out what x is. Guess what? This is a Pythagorean triple. This is a 8, 15, 17 right triangle. Since x is in quadrant 2, it's going left. X has to be a negative 15. That sign matters. We're supposed to figure out what sine, cosine, and tangent are of this. Let me just bring this down here. Sine of theta is y over r. That's 8 over 17. The directions told us that. Cosine of theta is x over r. That's negative 15 over 17. Tangent of theta is y over x. That is 8 over negative 15. Try to sum up some of this stuff. Positive and negative quadrants. In quadrant 1, you're going to have to go right and up, which means x and y are both positive. Since r is always positive, all of the trig functions in quadrant 1 are going to be positive. Because in all cases, you're dividing numbers that are positives by numbers that are positives. In quadrant 2, your x value is negative and your y value is positive. So in quadrant 2, sine's positive, cosine's negative, because cosine is x, which is a negative number over r. Negative over positive is negative. Tangent's also negative in quadrant 2, because if you divide a positive by a negative, you get a negative. So in quadrant 1, they're all positive. In quadrant 2, only sine's positive. In quadrant 3, both x and y are negative. Therefore, tangent is the only positive trig function. Because if you divide two negatives, you get a positive. In quadrant 4, x is positive and y is negative. Only cosine is positive in quadrant 4. Sine's negative because you have a negative over a positive. Cosine's positive because you have a positive over a positive. Tangent's negative because you have a negative over a positive. So this is helpful to some people. Some folks, it's not helpful at all. So if it's helpful, study that. If it isn't, then don't. In what quadrants can theta be if sine of theta is bigger than 0 and cosine of theta is less than 0? Here's what this is really saying. Since r is always positive, we can dismiss r in our thinking for this. Sine of theta is y over r. So if sine of theta is bigger than 0, this is really saying y is bigger than 0. This is referring to quadrants 1 and 2, because that's when y is positive. If cosine of theta is less than 0, that's really saying that x is less than 0. This happens in quadrants 2 and 3. So here it's 1 and 2, here it's 2 and 3. Where do those overlap? Those overlap in quadrant 2. So this has to happen in quadrant 2. B, sine and tangent have the same sign. Well, both sine, tangent, and cosine are positive in quadrant 1, so they have the same sign in quadrant 1. Quadrant 2, sine's the only positive thing, so sine and tangent can't have the same sign. In quadrant 3, tangent's the only one that's positive, so they don't have the same sign. In quadrant 4, cosine's the only positive one. That means sine and tangent are both negative. So quadrants 1 and 4, they have the same sign. That concludes the notes for 16.3.